Okay, so next we're looking at how do I use the sine and cosine ratios. So remember from before that we could use tangent of the angle to find the opposite side length or the adjacent side length. Or if I knew these two, I could calculate this one, right? And so there were two types of questions. Either I'm looking for an angle measure, so I'd have, say, something like the tan of A is 6/8, and then I did the inverse tangent of that to give me A, right? So hopefully you remember that. And the note that I want to make here is that when I'm looking for an angle measure, I use the inverse ratio. What do I mean by ratio? Sine, cos, or tan. Or I'm calculating the length of a side. I use the regular ratio. I don't press second function or shift or whatever it is on my calculator. And I have two types. Either the variables in the numerator, which means I multiply to solve, or it's in the denominator, which means I have to do a division. I have to divide. Okay, so this is really all there is to it. Okay. What is sine? The sine, again, A is the angle, but this time instead of being opposite and adjacent, now we're talking about the hypotenuse. So it's the ratio of the opposite over the hypotenuse, and cosine is the ratio of the adjacent over the hypotenuse. Now remember that sine and cosine, because the hypotenuse is in the denominator and the hypotenuse is the longest side, what do you think that's going to tell us about the value of sine and cosine of those ratios? Yep, I hope you said that they're going to be less than 1 in these triangles, because the denominator is always going to be bigger than the numerator. So let's turn our attention to these examples down here. Sine j. So the sine is, remember, the opposite over the hypotenuse. So the opposite is root 175, and the hypotenuse is 20. So that is the sine of that angle. The cosine of j is the adjacent over the hypotenuse. So the denominator is the same, but this time the adjacent side to j is 15. And now, whether I do either of these calculations, doesn't matter. Whether I do this one or this one, I'll get the same answer for j. So if I wanted to find angle j, I would do the inverse sine of root 175 over 20, or over here, j is the inverse cosine of 15 over 20. Okay, so it's the same sort of steps as tangent, except now we're relating either the opposite in the hypotenuse or the adjacent in the hypotenuse. All right, why don't you pause and see if you can correctly write cosine q and sine q, just the ratios, okay? So I hope you found that cosine q was the adjacent over the hypotenuse, and sine would be the opposite over the hypotenuse. All right, so that's just looking at the ratios. Can you identify opposite, adjacent, hypotenuse? Can you put them in the right spot? I hope you can. That's not too tough. Let's look at these problems down here. So determine the angle measure of the two acute angles in each problem. So I want to find this angle and this one. I already know that this up here is 90. So let's say we start with this angle up here. Let's call it A. If I'm at A, I want to decide in terms of opposite, adjacent, and hypotenuse, which one is this and which one is this. And then after I decide that, then I'm going to decide, am I going to use sine, cosine, or tangent? And then I'm going to make an equation. So think about that. Of opposite, adjacent, and hypotenuse, which two have we got? And then decide on which ratio we're going to use here. So Hopefully you saw that if this is our angle, we have the adjacent side and we have the hypotenuse, because this over here is the opposite and I don't have it. So I'm not interested in the opposite. If I'm dealing with adjacent and hypotenuse, that tells me I'm working with cosine. So cosine of angle A is adjacent over hypotenuse. And one trick to remember this is this mnemonic, SOHCAHTOA. Cosine is adjacent over hypotenuse. So this is what I'm working with here. So the cosine of angle A is 20 over 45. And I hope you remember how to find the angle of this triangle by doing the inverse cosine. So A would be the inverse cosine of 20 on 45, which I just calculated to be 63.6. All right, so if I know that that's 63.6, let's clean this up. I got a mess on there. This is 63.6. This other angle, I can do the 90-degree rule and say, or sorry, the 180-degree rule, and go 180 minus 90 minus 63.6 is going to be angle B. And that turns out to be 26.4 degrees. So I hope you found those two in there. This one, I have to start by drawing the triangle based on this information and do a similar calculation. So why don't you pause it here and try that? Okay, let's draw this out. So again, I just draw any right triangle. If it's not to scale, who cares? Doesn't matter. This time A is the right angle, and this is side A. And then either I put B here and C there, or vice versa. If you had C up here where I have B and so on, that's fine. In my triangle, this is going to be 9 over there. So let's try and find angle C first. And again, I'm going to go through these steps. Of opposite, adjacent, and hypotenuse, which two have I got? Well, I have the opposite and I have the hypotenuse. So in this case, I'm talking about sine. Sine of C is 9 over 14. So C is going to be the inverse sine of 9 over 14. And that turns out to be 40, almost exactly. So this is 40 degrees. By the 180-degree rule, this is 50, right? Boom, there we are, we're done. We found the two acute angles. And now we have two problems to look at here, which are going to use either sine or cosine. And it says that the pathway to a viewpoint is 6 kilometers. If the pathway increases vertically 950 meters, determine the angle of elevation. So let's assume that this is just something like that, right? Here's the pathway where you're walking along here. That is 6.0 kilometers. The hypotenuse, right? And the pathway increases 950 meters. Well, I need to be using the same unit, so I'm going to call this 0.95 kilometers. What is the angle of elevation? That's this angle here, angle A. So, again, I go through opposite, adjacent, hypotenuse. What are these? Well, this is my opposite, and this is the hypotenuse. So if I'm dealing with opposite and hypotenuse, now I decide what ratio is that. I hope you said sine. And now I'm going to do the calculation here to find out what A is, the inverse sine of 0.95 over 6, and that gives me 9.1 degrees. So I hope you found that 9.1 degrees there. And now this is talking about the position of some ships. The distance between a cruise ship and a lighthouse is 43 kilometers north, and a second ship is west of the, okay. So let's say the lighthouse is here. Here's my cruise ship. This is 43 kilometers. A second ship is west, so that would be this way. Let's call that whatever, S for ship, and it's 35 kilometers that way to the west. And there's my right triangle. What is the angle from the lighthouse to the two boats? So again, I'm going to go through those steps. Opposite, adjacent, hypotenuse. And I think I'm seeing a pattern here in these last three questions. But I'm dealing with the opposite, right? This is my opposite. And, oh, no, I'm not. Sorry. I'm not seeing a pattern. This is the adjacent, ADJ. I thought I was going to be dealing with sine again, but I'm not. This is a tangent question. So tangent of L is 35 over 43. I have to do the inverse tangent. And angle L turns out to be 39.1 degrees. Okay, so that's using sine and cosine to find an angle.